Okay, so I'll just jump into the second part of the practice test here for Chapter 1. And in problem 24, I'm going to be asked to shade the region of a two-circle Venn diagram that represents A complement intersection B. So I'll set up to write my answer down here in a bit. And when we did this in the section, what was it, 1.4 maybe 1.5, what we did is we started with a generic Venn diagram with the sets A and B. We filled them up with some numbers for each of the regions, so I did like a region 1, a region 2, a region 3, and a region 4. And then we created some sets. For instance here, the universal set is going to be the numbers 1 through 4, which are the four numbers that I've just written. The set A would be the two numbers in the A circle, which would be 1 and 2. The set A complement would be the numbers in the universal set that aren't in set A. So if I remove 1 and 2 from set A, I get A complement, which would be the set containing 3 and 4. Set B would be the two numbers in the B circle, which is 2 and 3. And I don't need it for this problem, but B complement would be what you'd get when you remove the two elements of B from the universal set. You'd get 1 and 4. This is something that if you're going to use a note card on the test, I'd probably put this on my note card so you don't need to recreate this. Now that I have the sets that I need, I'm going to find out what A complement intersection B is by replacing this symbol A complement with the set containing the numbers 3 and 4. I'm going to leave the intersection sign, and then the symbol representing B, I'm going to put the numbers 2 and 3. And I'm going to intersect these two sets, and when you intersect sets, you find out what the sets have in common. These sets have in common the number 3, so when I intersect these two sets and combine them down to a single set, I'm going to get the set containing the number 3. And that immediately is going to help me get my answer. The answer that I'm going to write is going to shade the region that corresponds to the number 3, and that's going to be kind of this part of the B circle, the part of the B circle that doesn't overlap with the A circle. And that would be all I'd write for my answer to question 24. Question 25 wants me to do the same sort of thing, create a sketch of the regions that are defined by A union B intersection C complement. And to do this, I'm going to draw a 3-circle Venn diagram in my answer, and I always go and label my sets like that. And again, I'm going to create a Venn diagram, fill it up with numbers, and use those numbers to help me figure out what regions I need to shade for my answer. And this is another thing that you should probably just have on your note card so you don't need to take the time to recreate this. But I'm just going to do region 1, region 2, 3, 4, 5, 6, 7, and 8. So for this problem, the universal set would be the numbers 1 through 8. And then I'm going to be a little more efficient and not create every set. I'm only going to create the sets that I need. A, that's going to be the 4 numbers. Set A is going to contain the 4 numbers in the A circle, which is 1, 2, 4, and 5. So I need set A, because that's the first set called out. I also need set B. Set B is going to be the 4 numbers in the B circle, which is 2, 3, 5, and 6. I think I could get C complement. C complement would be any number that's not in the C circle. So if I cover up the 4 numbers in the C circle, what I have exposed is C complement. C complement's going to be 1, 2, 3, and 8. So I've just created the 3 sets I'm going to need to answer question 25. And now let me work from left to right. I'm going to first find A union B. And to do A union B, I'm going to take the A set, which is a set containing the numbers 1, 2, 4, and 5. And I'm going to union that with the B set, which is a set containing 2, 3, 5, and 6. I'm going to take those 8 elements and union them into one big set that has 8 elements, so 1, 2, 4, and 5, 2, 3, 5, and 6. If any number occurs more than once, I'll cross out the duplication, so I'm going to cross out the duplicate 5, and now I'm going to write the numbers in a nice order. I'm going to cross out the duplicate 2 as well. And I'm going to write the numbers in a nice order, so 1, 2, 3, 4, 5, 6. So the A union B part of this gives me the set containing 1, 2, 3, 4, 5, 6. So what I'm asked to do in this problem is to do A union B and then intersect it with C complement. Well, I can replace the A union B part of this with the set containing the numbers 1, 2, 3, 4, 5, and 6. Now I need to do my intersect, and I'm going to intersect with C complement, and in place of the symbol C complement, I'm going to write the set containing the numbers 1, 2, 3, and 8. And now I'm going to intersect these two sets, and to intersect sets, you write what the sets have in common. So the intersection of the A union B set along with the C complement set is going to be the set containing the numbers 1, 2, and 3. These are the regions that I'm going to need to shade in my answer, and regions 1, 2, and 3 are kind of on the top of my diagram, so I'm going to shade those regions in. I'll call this my answer to question 25. So question 25 has region 1, region 2, and region 3 shaded in. If your shading doesn't cover up goes outside the lines, I hardly care, and if it doesn't cover up the circles perfectly, I hardly care, just as long as I can tell which regions are shaded. Okay, so I'm going to basically do the same thing for 26. I'm not going to be so clever. I'm going to find A complement intersection B for the sets in this Venn diagram, and I need to find a set for A complement. A complement is any element that's not in the A circle. So if I cover up the elements in the A circle, the elements that aren't in the A circle are the elements of A complement. So A complement has the letters H and I. And then I need to intersect it with B. B is any letter in the B circle, so that's going to be the letters G and H. So for this Venn diagram, to do A complement intersection B, I need to take the A complement set, which is a set containing the letters H and I, and intersect that with the set containing the letters G and H. When you intersect two sets, you find out what the sets have in common, and these sets have in common the letter H. So my answer to problem 26 is just going to be the set that contains the letter H. It would be completely fine if you just wrote the set without the problem next to it, but if you want to, it wouldn't be wrong to say A complement intersection B equals the set containing the letter H. Both of these would be acceptable answers. Problem 27 wants me to do A union B intersection C complement for this diagram. So let me find out what these three sets are. First thing I'm going to do is find out the set for A, and A is going to be the four numbers in the A circle here, which is 4, 7, 8, and 11. So set A represents the set containing the numbers 4, 7, 8, and 11. Set B is going to be the numbers in the B circle, which are 4, 6, 8, and 10. And set C complement is going to be the numbers outside the C circle. So if I cover up the C circle, the 4, the 7, and the 10, and the 11 that I haven't covered up are the C complement. So those are the sets I'm going to need. And now let me figure out how to get through this. First I'm going to do A union B. To do A union B, I'm going to write the 4, 7, 8, and 11 in place of the symbol for A, and the 4, 6, 8, and 10 in place of the symbol for B. When I union two sets, I usually start off by just taking all the elements and jamming them together in a big set, and then I get rid of any duplication. Here there's a double 4 and a double, not a double 6, a double 4 and a double 8. That 6 needs to be in my set. And I write the numbers that are unique in a nice order. So I'm going to write 4, then the 6 that I mistakenly crossed out, 7, 8, 10, and 11. So that's the A union B part. I'm supposed to do A union B intersection C complement. In place of the A union B, I'm going to put the set containing the numbers 4, 6, 7, 8, 10, and 11. I'm going to leave my intersection symbol, and in place of C complement, I'm going to write the set containing 4, 7, 10, and 11. And since I'm intersecting these sets, I find out what they have in common. And what they have in common is they have a 4, a 7, and 10 in common. So the answer to my problem is just going to be the set. I don't need to shade in these particular problems. I just need to write the set that results from the operations. So I'm just going to write my answer is the set containing the numbers 4, 7, and 10. If I was clever, because A union B intersection C complement gives these three regions of the Venn diagram, I could have known that because I'm doing the same set operations, that I just needed these regions. I could have just taken that number, and that number from the shaded regions and made my answer. But I didn't do that so much in the video, so I didn't want to just introduce that now. Last couple problems are word problems. And I need to pull out some stuff that I have laying around here to make these easier for me. So these are the word problems that we solve with Venn diagrams. And for this particular problem 28, a company is considering manufacturing a couple different flavors of ice cream. They're considering bubblegum and boysenberry. They survey 120 people, and some of them like the bubblegum, some of them like the boysenberry, some of them liked both types. I'm going to create a Venn diagram to model the situation. I'm going to make the left circle for bubblegum and the right circle for boysenberry. Not feeling like writing those words. And in a word problem for the Venn diagrams that has two circles or two sets, I need to put in region 2 first, and that's usually the number that's given. And in this particular case, the region 2 number is going to be the 20 people that were surveyed that liked both types. After I do region 2, I'm going to do region 1, and I'm going to subtract the middle number. Specifically, that's the bubblegum circle. I'm going to take the bubblegum number and subtract the number in the middle and put those 20 in region 1. After I do region 1, I'm going to do region 3, and I'm going to subtract the middle number. I'm going to use the boysenberry number because that's the boysenberry circle. I'm going to subtract the middle number, and it's going to give me a 70. And then the last region I'm going to get is outside. And to get the outside, I'm going to add up all the numbers and subtract from the total. And the total is hidden in the sentence above. So I'm going to add up all the numbers, 20 plus 20 plus 70. Those add up to 110, and I'm going to subtract that from the total number. So I'm going to do 120 minus 110, and that will give me a 10 that goes outside the region. So that's done with my Venn diagram. Now I need to answer the question, how many liked only boysenberry? Well, there are 90 people of the 120 that liked boysenberry. 20 of the people that liked boysenberry also liked the bubblegum. 70 liked the boysenberry but not the bubblegum. This problem right here is just calling out those 70 of the 90 people that like boysenberry. It's this region right here because they're in the boysenberry circle, so they liked boysenberry. They're not in the bubblegum circle, so they didn't like bubblegum. One more problem to do, and another word problem, and this is going to be a 3-circle Venn diagram. So in this problem 29, 150 students were asked which of these 3 teachers they've taken. Some have taken Clark, who teaches chemistry, some have taken me, and some have taken Dr. Diaz. He's retired now, so I should probably update this, but just out of respect to him, I'll keep his name around. He taught psychology. So I'm going to make a 3-circle Venn diagram, one for Clark, one for Grima, one for Dr. Diaz. And in a 3-circle Venn diagram, the first thing I'm going to fill in is region 5, and that's a given number. So for region 5, dead center, that's going to be the number of people that have taken all 3. This is going to go for region 5. There's going to be 5 of the 150 students that have taken classes from each of the 3 teachers. After this, I'm going to do region 2, which is right above, and I'm going to subtract the number in the middle. So region 2 is in between Clark and Grima, so I'm going to look for the number that has the names Clark and Grima, which is this 10, and I'm going to subtract the 5 that's in the middle, and that will give me a 5 in region 2. Next, I'm going to do region 4. I'm going to subtract the number in the middle. Region 4 is in between Clark and Diaz, so I'm going to look to the Clark and Diaz line, and I'm going to subtract the number in the middle, which is the 5, and 20 minus 5 is 15, and that's going to go right there in region 4. Next, I'm going to do region 6 and subtract the number in the middle. Region 6 is between Grima and Diaz, so I'm going to pull that number right there. I'm going to take that number 15. I'm going to subtract the number in the middle. 15 minus 5 is going to give me 10. And that will fill in that part of the diagram. Then I'm going to do region 1. I'm going to add up 3 numbers and then subtract. So to do region 1, because that's the Clark circle, I'm going to use that Clark figure right there. I'm going to add up these 3 numbers, the 15, the 5, and the 5, which are the numbers in the Clark circle. Those add up to 25. Those are the 3 numbers I'm going to add up. And now I'm going to go to the Clark name and go 45 minus 25, and that will give me a 20 for region 1. Next, I'm going to do region 3, and I'm going to add up 3 numbers and subtract. Region 3 is going to be there. I'm going to add up the numbers in the Grima circle, which is 5, 5, and 10. Those add up to 20. I go up top and find the Grima number, name. I go 50 minus 20, and I get 30. I don't know if this was being, conceited, making myself the most, but oh well. Here's what it is. And then I'll do region 7. I'm going to add up 3 numbers in the Diaz circle and then subtract. So for region 7, the numbers I'm going to add up are the 15, the 5, and the 10 in the Diaz circle, and those add up to 30. And I'm going to subtract it from the Diaz name number, and it's 40 minus 30, which is 10. Lastly, I need to do region 8. I add up all the numbers and then subtract from the total. So now I need to add up these 20, 5, 30, 15, 5, 10, and 10. Oh gosh, 50, 70. I think this adds up to 95. And I'm going to take the total of 150 and subtract it from that 95. And that will give me the number that goes in region 8, which is outside the circles. And I get 55 for that. So that's everything I need for question part A of 29. And now I'll answer the 2 questions. How many have not taken any of the 3? That's just the number outside the circles. That's the 55. And then how many have taken both Grima and Diaz? So the ones that have taken Grima and Diaz are those right there, those are the overlapping parts of the Grimmett and Diaz circle. So I'm only focusing at first on these, because these students right here, they're in the Grimmett circle and they're in the Diaz circle. They're in both the Grimmett and the Diaz circle. So these are the ones, just reading that part tells me to focus on. After I go past the comma, it says, but not Clark. So of these 15 students that have taken both Grimmett and Diaz, I only want the ones that haven't also taken Clark. So I'm going to ignore those 5 because those 5 are also in the Clark circle, and I'm only going to keep those 10. The answer to part C here is going to be these 10 students. That's everything there is for this part of the practice test. So if you can do all the problems on both parts of the practice test, you should be perfectly ready for the test that we get over Chapter 1, which is our first test. The nice thing is you are allowed to do 1 retake at the end of the semester. We do 4 tests this semester, and whatever test you do poorest on, if you want to retake it, you can retake it at the end of the semester. But if you perfect the problems, the 29 problems between the 2 practice tests, there shouldn't be any surprises on the test, and hopefully you do really well.